Welcome everybody to Algebra 2, Section 1.3, Graphing Inequalities, Interval and Set Notation, and Solving Multi-Step Inequalities. So let's first talk about graphing inequalities. When you're graphing them, we're going to use a closed dot or circle for whenever you have less than or equal to or greater than or equal to symbols. Whereas we're going to use an open circle whenever the symbols are less than or greater than. So the difference is whether or not the number is also equal to the variable or not. So let's go ahead and practice this a little bit here, okay? So for number 1, x is greater than 4. So we go and find 4 on our number line, and we make a circle. And you can make the circle either on the number line or directly above the number line. I'm going to make it on myself. And whether the circle is open or closed, once again, depends on whether or not we have this or equal to symbol. It doesn't have the or equal to symbol, so it's an open circle. Now we have to say what direction will our arrow go? What are our range of answers? Because an inequality tells us a range of answers rather than an equation which just tells us one specific answer. So we're saying x is greater than 4. So all of these numbers over here are greater than 4. Now if you have a color like I do on my iPad, then you can draw it on the line pretty well there. But if you're doing it in pencil, it's kind of hard to tell where your arrow's going, whether it's going left or right. So a good idea can be to draw it like this up above the line to help you out. And so that's telling us anything bigger than 4 is an answer. On number 2, we go to -7. We're going to make a circle, and this time it'll be a closed circle because it's or equal to. And our arrow will go to the left this time because these are the numbers that are lower than or less than -7. And this open circle on number 1 told us that 4 is not part of the solution, but everything bigger than it is. Or on number 2, we're saying everything less than and equal to, or equal to, -7 are part of the solution. If you ever need help trying to figure out which way your arrow is going to go and you're having a hard time with that, a little trick is when your variable's on the left side of the equals of the inequality sign. I said the equal on accident. When it's on the left side of the inequality sign, like we see on 1, 2, 3, and 4, you can match the inequality symbol with your arrow. So they're both kind of like right arrows there on number 1. And number 2, they're both kind of like left arrows there. And now once again, that'll work when your variable's on the left of the inequality symbol. So on number 3, x is greater than or equal to -2. Make my circle at -2, and it is closed since it's or equal to. And I go to the right. Now, if you draw your arrow that far, that's good. If you draw your arrow that far, that's okay. If you draw your arrow all the way over here, that's okay too. Basically, I'm not going to be very picky how far your arrow is over as long as it's going the right direction. X is less than 11 on number 4, so I make an open circle at 11, and it's going to go to the left because those are the numbers lower than 11. Now let's talk about interval notation. Interval notation is a way to write the solution to an inequality using infinity symbols, parentheses, and brackets. And essentially the idea is we're saying the solution to the inequality exists between this interval or between this range. And just like we have open and closed circles for the graphs, telling us whether it's closed or open, or aka whether the number is part of the solution or not, parentheses and brackets tell us the same things. So parentheses are used when the number is not included or there's an open circle. And brackets are used when the number is included in the solution or there's a closed circle. So let's go ahead and practice this on 5 through 8 here. So here on 5 through 8, we're going to go from left to right when we do inequality or interval notation. And so the farthest left the solution goes is -3. So we see it here halfway between -4 and -2. And we're going to put a comma. And the farthest right it goes is forever. So we can't put 8 or 9 because it goes farther than 8 or 9. Instead, we're going to put infinity because it goes all the way forever to infinity. So we're going to put on -3 a bracket, because it's a closed circle and the answer includes -3. Now for infinity, we don't see a circle. So the question becomes, well, do we put a bracket or parentheses? And one way to think about it is that part of the solution? Can you actually plug in infinity? Is infinity a number we can work with? And the answer is no, it's not. Infinity is a concept, not an actual number. So we're going to put a parentheses there anytime you have infinity, because you can't actually reach it. On number 6, from left to right, the farthest left it goes is 8. The farthest right it goes again is infinity. This time 8 is not part of the solution, so we're going to put a parenthesis there. And infinity is also not part of the solution, but anything smaller than infinity is, anything leading up to infinity is. 7. On 7, the farthest left we go is forever left, and so that would be negative infinity. It's the same idea as going infinitely bigger, just now we're going infinitely smaller. Comma, the farthest right we go is negative 1. So for negative 1, we'd have a bracket because it's a closed circle and includes that answer. For negative infinity, just like we did with positive infinity, it would be a parentheses because it's a concept, not an actual number we can plug in and get to. On number 8, similarly to number 7, it'd be negative infinity, comma, this time it'd be 5, and it'd have an open circle, so it's parentheses for 5 and also parentheses for negative infinity. Now set notation. Set notation is another way to write an inequality. And essentially it's almost like a fancier way to write it, a more formal way to write it. And it's not as commonly used in Algebra 2 or before, but it is more commonly used once you get to college algebra. So we're going to go ahead and show it here. So if we had the inequality x is greater than 5, the set notation would look like the following. And you probably notice that that looks incredibly similar to the original example. Some notable changes are there's a line here, there's another x before the line, and we have these fancy looking braces. Now don't be super concerned if you can't draw those braces very well. It takes practice, number 1, and number 2, they're a little bit weird to draw, so some of us are going to struggle more with them. And that's okay, as long as I know what you're trying to write, I'm fine with it. So the parts in the light blue are new, where the parts in the purple are old. So let's talk about what this means, like how you would say it. So you would read it as the set of x values such that x is greater than 5. So the idea is we're saying, here's what we're talking about. We're talking about x. So the set of x values. This line essentially means such that. So we're saying, we're talking about x values. It has to be something. And then here's what we're saying it has to be. So the x values is what we're talking about. It has to be something. Here's what it has to be. So it's almost just kind of like there's a preview and just, once again, a more formal way to write it. And those braces just tell us when it starts and ends. So now we're going to practice writing these inequalities. So we're going to take these graphs and we're going to write the interval notation and the set notation for each of them. And I would encourage you to pause throughout this part and work on any examples that you can do on your own. So maybe you watch the first example and then pause it to work on following ones, or maybe you pause it now and just work on them already and then come back and resume the video and see how you do. So number 1, the farthest left we go is negative infinity, where the farthest right we go is negative 4. Negative 4 is an open circle, so it's a parentheses, and infinity and negative infinity are always parentheses. For the set notation, we're going to say x such that, and then we have to write our inequality. X is compared to negative 4 somehow, so our question becomes, is it less than or greater than? Well, these numbers are lower than negative 4, and so it's less than negative 4. Another way to remember that is, remember this arrow, it's like a left arrow there, matches this, which also kind of looks like a left arrow there. And then we can't forget our braces to start and finish it. Number 2, for our interval notation, our smallest number is 3, the farthest left it goes, and the farthest right it goes is infinity or forever. Infinity is always a parenthesis, but 3 is a bracket because it's a closed circle. For set notation, it'll be x such that, and then we'll write our inequality. X is greater than or equal to 3. Greater than or equal to, it's greater than because it goes to the right, and those numbers bigger than 3, and it's or equal to because it's a closed circle. And then I'll put my braces around it. Number 3, interval notation, the farthest left we go is negative infinity. The farthest right we go is negative 13. Negative 13 is a closed circle, so it's a bracket. Negative infinity is always going to be a parentheses. On set notation, we're going to have x such that x is less than or equal to negative 13, because those are the numbers smaller than negative 13. Number 4, we have the farthest left is not negative, my apologies, 11, and the farthest right is positive infinity. And both are parentheses in this case. And the set notation would be x such that x is greater than 11. And we have the braces as well. Next, we have number 5. For interval notation, we have 3 comma infinity. 3 is a bracket, infinity is a parenthesis, and the set notation x such that x is greater than or equal to, because it's a closed circle, 3. A few more examples here. Number 6, forever negative, so negative infinity to 10 on the right, both are parentheses. Set notation is set of x values such that x is less than positive 10. I almost said negative 10. Number 7, it goes left to negative 1, it goes right to infinity, and we have parentheses on both. Set notation would be the set of x values such that x is greater than negative 1. Number 8, it goes forever left, so negative infinity. Forever to the right, it goes to negative 19, so that'd be a bracket on negative 19 because it's a closed circle. A parentheses on negative 18, or excuse me, on negative infinity. And then our set notation is the set of x values such that x is less than or equal to negative 19. Now we're going to work on solving, graphing, and writing these in interval notation. Now we're going to be, like I said, solving first, and then once we're done solving it, we're graphing like we had been, and then using interval notation. So it's like we're adding an extra step and combining some steps here. Now when you solve inequalities, it is almost entirely similar to equations. However, one notable difference is that when you multiply or divide by a negative, you have to flip the inequality symbol. And I'll show an example of this. So if I were to have negative 3x is greater than 27, and I divide by negative 3, I have x, I have negative 9, but I have to flip the symbol here. X is less than negative 9. If I were to not flip the symbol and leave it as so, and I were to try and plug in a number to test to see if it works, I'd plug in a number greater than negative 9. For example, 0 is greater than negative 9. So if I plugged in 0 to my original problem, that'd be like negative 3 times 0 is greater than 27. So that'd be like saying 0 is greater than 27, which just is not true. However, if I instead say, after flipping my inequality here, that it's less than negative 9, I pick a number smaller than negative 9, such as negative 10. So I plug in that number, whatever number smaller than negative 9 I want to pick, and I test it out. Now I have positive 30 is greater than 27, and that's true. So whenever we multiply or divide both sides of the inequality, we have to flip the symbol. So once again, to multiply or divide both sides of an inequality. So it's not the case if you multiply just one side of the inequality or divide just one side of an inequality, but it's the case if you do it to both sides of the inequality. I also want to note you also have to flip the inequality symbol if you're flipping the entire inequality around, such as if I have 5 is greater than x, and I want to switch it around so x is on the left and 5 is on the right, I have to switch it around so 5 is still being regarded as bigger and x is still being regarded as smaller. So I have to make it x is less than 5. So that way the inequality symbol flips then as well. Let's go ahead and start solving these. So on number 9 here, solving it, I would subtract 5v first from both sides personally to try and move my smaller variable toward my bigger variable. So that'll give me 2v. I would also add 17 to both sides to move my numbers to my opposite side of my variables. So my variables on my right, I want my numbers on the left, the opposite. So adding 17 gets me 18. Nothing would change our inequality symbol because we didn't multiply or divide both sides by a negative. Now I would divide by 2, and dividing by 2 gets us 9 is greater than b. Now we do prefer the variable on the left, so I would encourage you to flip it around here. And like I talked about a moment ago, if we flip it around, we have to flip our inequality as well. So v is less than 9. That's our answer. Now we have to graph it and write it in interval notation. So we have a number line here, a blank number line that we can fill out. So put 9 somewhere on this number line, probably somewhere in the middle, and put maybe a couple numbers to the right and a couple numbers to the left that are bigger and smaller than it. And if you want to go all the way out and keep going with like 12 and 13 and 14 and 6 and 5, feel free. Or if you want to stop before that, that's also okay. Realistically, we just kind of need one number in each direction. So I wouldn't even necessarily need 7 and 11 there if I don't want to. But having them isn't wrong either. And so then I'm going to do my circle, so I'm going to do an open circle at 9 going to the left, because those are the numbers less than 9. Interval notation, we're going forever negative, so negative infinity, forever to the left, and to the right we're going to 9, and then both are parentheses. And that's number 9. Like I've talked about before, I'm going to encourage you to pause the video, try as many of these as you can on your own, and then continue the video. So moving on to number 10 here, if I start solving this, a good first step would be distributing this 3 and regarding it as a negative 3 to distribute it. So I got 21x minus 15x minus 27 is greater than or equal to 7. Now because I didn't multiply or divide the entire inequality or both sides, I don't flip the symbol. I only multiplied part of the inequality. Now combining like terms, 21x minus 15x is 6x. And I'll add 27 to both sides to move it away from my variable. So I get 6x is greater than or equal to 34. Dividing by 6x on both sides, or 6 on both sides, not 6x, gives us a fraction because 6 doesn't go into 34 evenly. It would end up giving us the fraction negative 15, sorry, I was going to say negative 15 over 2, that's incorrect. It gives us the fraction 17 over 3. If you want, you can make that a decimal. If you were to make that a decimal, make sure you don't round unless you're asked to. So call it x is greater than or equal to, in this case it'd be 5.6 repeating. Either one of those would be acceptable. I don't really care. I'm going to include both here in this case. So now I'm going to make my graph. And if you make your graph, you could do a couple different things. If you want, you could do like 5.6 repeating. You could do, then you could do like 5.7. You could do 5.8. You could do 5.9. You could do things like that. You could also go up by thirds if you wanted and call it like 6, 6.3 repeating, 6.6 repeating, stuff like that. Another way you could do it is you could call this like 6, 7, 8, 9, 5, 4, 3, go as far as you want in each direction. I can go further if I wanted. And then I could place my circle between 5 and 6, but slightly closer to 6, because 5.6 repeating is slightly closer to 6. So 2/3 of the way across approximately. I'm not going to take out some sort of ruler and measure just how far along you are to make sure it's exactly 2/3 of the way from 5 to 6. And then my arrow is going to go to my right because those are the numbers bigger than 5.6. And so my interval notation would be 5.6 repeating, or 17 over 3. You could do the fraction as well. Either one is perfectly fine. I don't really care between the two. And then that'd be a bracket, because it gets there as a closed circle, comma, infinity, which would be a parentheses. Number 11, 12p plus 52 is greater than negative 2 times the quantity of 4 minus 2p. So we could start by one of two ways, either distributing negative 2 or dividing both sides by negative 2. Distributing negative 2 prevents you from having to adjust the left side yet and flip the inequality. Dividing by negative 2 would require you to flip the inequality symbol, but it would make your number smaller. So it's really up to you, whatever you want to choose. Because yeah, everything here divides well by 2. So as long as you divide everything, it's okay. So on this problem, let's say I go ahead and just divide both sides by -2, just because. Once again, if you were to distribute your -2, you'll still get the same answer. You should, at least, assuming you do your math correctly. So I'd get -6p minus 26, and on the right side, those -2's reduce, and I just get 4 minus 2p, what was inside the parentheses. But now, since I multiplied or divided both sides by an inequality by a negative, I have to flip my inequality symbol. So now as I continue solving, I move my smaller variable to my bigger variable to make my life a little bit easier by adding 6p, and I get 4p. I'm also going to move my 4 to my other side to match it with the other number and get it away from my variables and get -30. Then if I divide by 4, I get -15 over 2 is greater than p. You could also call that -7.5. And so I'm going to go ahead and flip it around and say p is greater than -7.5. And once again, if you call it -15 over 2 or -7.5, I don't really care, or -7.5 even. So now I'm going to go ahead and graph this, and once again, you could go up by halves if you want to, do like -7.5, -7, -6.5, or you could do just whole numbers, or just integers, -6, -5, -8, -9, whatever's fine. Open circle at -7.5, and the arrow is going to go to the right. The interval notation, it goes left to -7.5 or -15 over 2. It goes right to infinity, and both are parentheses here. Number 3, 3 minus quantity of 4m plus 1 is greater than or equal to 5m minus 25. So I first need to make sure I'm distributing this negative to subtract the entire parentheses. So now as I combine the 3 and -1, I get -4m plus 2 is greater than or equal to 5m minus 25. So now I'm going to add 4m to both sides, move my smaller variable toward my bigger variable, and get 9m. If you subtracted 5m to move your variables to the left, so that way they're already there, you don't have to flip it around later, that's also okay. And I'm going to add 25 to both sides and get 27. Then we'll divide both sides by 9, and thankfully this divides well, and we get 3 is greater than or equal to m, which I'll flip around to make it m is less than or equal to 3. So now we're going to go ahead and graph that. Put 3 somewhere around the middle. Put a number smaller, a number bigger. You can keep going with numbers if you want. I'm going to do a closed circle since it's or equal to. 3 is included in our answer, and it's going to go to the left. And my interval notation, it goes forever negatives, so -infinity. To the right, it goes to 3. I'm going to do a bracket there since it's a closed circle, and a parentheses since it's infinity or -infinity. Number 13 here. This one, you could try and divide both sides by 3 and then divide both sides by 4 next. However, it's going to create a little bit of a mess here because then you're dividing multiple things at the same time. That can get a little bit hairy. And also, only 8 divides well by 4. 9 doesn't divide well by 4, so you're going to be dealing with some fractions in that case. So I would just encourage you, when you're distributing on both sides, just to go ahead and distribute. So 3 times 8x is 24x, 3 times -9 is -27, 4 times 6x is 24x, and 4 times 1 is 4. You might be wondering, which x do I move? It's really your preference, but in this case, actually, it doesn't matter at all because they're the same. So just try moving one of them by subtracting 24x. Just pick one, and it happens to be either one that you picked. It doesn't really matter, and you end up getting 0. We do not just put x. If I put x minus 27 here, that means it's a 1x. That's not the case. There's no x's. So I'm going to just write -27 is greater than 4. Now we look at the statement and we say, there's no equation, or excuse me, there's no variables. Is this a true statement? Is this a true inequality? Is -27 greater than 4? And the answer to that is no, it's not. So our answer is that there is no solution. No matter what you would plug into this inequality, nothing would ever make it work. So you might be wondering, well, how do we graph no solution? And the answer is you don't graph no solution. There's no solution to graph. There's no visual representation of nothing. Now our interval notation, you could just put like NA for not available or not applicable or none, or you can do this little circle with a line through it. The circle with a line through it does not mean O. However, it does mean the empty set, and that just means there are no answers. So it's the same thing as no solution. So you could just put none, not available, not applicable, the no solution, or the empty set symbol like I just did there. Number 14, continuing on solving these. So I'm going to distribute the 10, distribute the 9, and then combine like terms, rather than dividing everything by 10, everything by 9, and creating a bunch of fractions that I have to deal with. So if I multiply by 10 on the left-hand side to that parentheses, I get 10a minus 30 minus 13a is greater than, less than or equal to 9a minus 72. Combining like terms on my left side gives us negative 3a minus 30 is less than 9a minus 72. If I add 3a to both sides, I get 12a on the right side. If I add 72 to both sides to move my number away from my variables to the opposite side, I end up getting 42. Dividing by 12. 12 does not go evenly into 42. It does make a decimal, and the decimal makes is 3.5. If you made it a fraction, that'd be 7 over 2 would be what it reduces by. 6 goes into both 42 and 12 to get that. I'm going to go ahead and flip that around and get a is greater than 3.5 or 7 over 2. Going to go ahead and graph. Once again, you can go by decimals, you can go by fractions, you can go by integers, you pick. I'm going to put 3, 4, 5, 2, 1, do an open circle between 3 and 4, approximately halfway across, and draw my arrow to the right. Now notice, we are doing set notation here. So we're no longer doing interval notation. Remember, set notation is this, but we add the A and that such that line and the braces. So A such that, and I just rewrite this version. Now when you do set notation, your variable has to be on the left-hand side of that inequality. So make sure to flip it if it's not already on that side of the inequality. Number 15. I'm going to distribute this negative 7 to the parentheses and the 3 to the parentheses rather than dividing everything by those numbers and creating a bunch of fractions and decimals in this case because it doesn't go evenly into all these numbers. So I'm going to make that plus a negative 7, and I'm going to get negative 14r minus 21 is less than or equal to 3r minus 30. Combining like terms on my left-hand side, we get, that was quite sloppy, let me fix that, negative 14r minus 13. Now if I add 14r to both sides, I get 17r, and I add 30 to both sides, I get 17. If I divide both sides by 17, we get 1 is less than or equal to r. Flipping that around, so that way my variables on the left gives us r is greater than or equal to 1. I'll go ahead and graph that. Put 1 somewhere in the middle, a number smaller, a number bigger. You can do multiple numbers if you want, keep going. Closed circle to the right. Set notation would be r such that r is greater than or equal to 1. Number 16, going to go ahead and distribute here again. Negative 6p minus 24 is less than negative 8p minus 24. So my smaller variables are my negative 8p, and so I'm going to add that to both sides and get 2p. I'm going to add 24 to both sides, but I'm actually going to do that in the next step here to make things a little bit more clear. Typically I do that in the same step, but I want to emphasize what's going to happen in this part. It's the only reason I'm doing it separately this time. So if I add 24 to both sides here, I end up getting that to equal 0, and this equals 0. So we can't just leave that blank or say no solution. Instead, we have to actually write what it is, which is 0. And we continue solving because 0 is a number. So how I would solve if any other number was on that right-hand side is the same way I'd solve if there's 0 on that side. And that's by dividing by 2 on both sides. 0 divided by 2 is 0. 0 divided by any other number is always going to be 0. And so that's my answer. Anything less than 0 would work. So I'm going to go ahead and graph it, put 0 somewhere in the middle-ish, number bigger, number smaller, you can keep going if you'd like, an open circle to the left. The set notation would be p, or a set of p-values such that p is less than 0. And draw the braces. Almost done here. We got 2 left. Number 17. Going to go ahead and distribute there on the right. Make sure we change these signs. And I'm going to start combining some like terms on the right as well. So I'm going to combine that 6x and that positive 5x to make 11x. Notice here they're both 11x. If I subtract 11x from each side, I get 0 x's. I might write that out to emphasize that as well, like I did on the last one. And so you get -4 is less than or equal to -3. Now, is that true? Once we get down to no variables, we ask ourselves, is it true or false? Is -4 less than or equal to -3? And the answer is that it is true. It is less than -3. -4 is a bigger negative, so it is a smaller number. And so this is going to be infinitely many solutions. How we graph this is we just draw an arrow all the way across, saying it goes forever left, forever right, and everywhere in between. Now, set notation for this is a little bit unique. So here we'd have the set of all x values such that x is what we call an element. So this weird looking E thing where I kind of curved it. I did like a C, one other line. It kind of looks like an E now, and it's called an element. X is an element or part of the real number system. So remember a couple lessons ago we were talking about the real number system where we use that R or the double-lined R. And so we're saying as long as x is any real number, then it is part of the solution. So as long as it's a real number, which are all the numbers we've talked about up to this point, then it'll be part of the solution. Now you might be wondering, how would this have worked if this was interval notation? So let me show the interval notation on this one as well real quick. So the interval notation on this problem, it goes forever left, so that's -infinity. It goes forever right, so that's positive infinity. And it would look just like that with parentheses because infinity and -infinity always have in parentheses. Last up, number 18. So we have this fraction here. I can either try and actually divide each of these by -2, or to make my life a little bit easier, I can actually just multiply everything times -2 or -2 over 1. Those -2's reduce, and on the left side of this inequality, we have 4 plus 5 times the quantity of 2w minus 10 is less than. On the left side, we still have to multiply this by -2, which actually reminds me that it won't be less than anymore since I'm multiplying both sides of this inequality. It'll be greater than. Since I forgot to finish my thought, I'm multiplying both sides of the inequality by a negative. So multiplying -2 to both, we get -2w, and I get -14. Our next step is distributing the 5. You could have chosen to distribute 5 in that same step above if you prefer. So now if I distribute the 5, I get 10w minus 50. And nothing else has changed so far. So I just rewrite all of it. Now if I combine like terms on the left-hand side, I get 10w minus 46 is greater than -2w minus 14. Combining my w's by moving my smaller w to my bigger w by adding it gives me 12w. Moving my numbers to the opposite side of the variables by adding 46 gives me greater than 32. Now if I divide both sides by 12, 12 does not go evenly into 32. However, it does reduce by 4. 4 goes into 32 8 times. It goes into 12 3 times. So you can make that a fraction, or you can make this a decimal. W is greater than 2.6 repeating, or 2 2/3. I'd be fine with any of those scenarios. Go ahead and graph it. And so 2 and 3, it'll be between the two. So I'm doing a couple extra numbers this time, I guess just because randomly, you don't have to one way or the other. I just happened to do it this time. And I'm going to do an open circle at 2.6 repeating. So, or 8/3 or 2 2/3 are all the same thing, just said different ways. And so that'd be 2/3 the way from 2 to 3. And so I'm going to put an open circle there-ish. That's approximately what I'm talking about. It doesn't have to be perfect. Once again, I'm not pulling out a ruler to check. And my arrow is going to go to the right. So now I have to do my set notation. The set of numbers W, such that W is greater than, right, 8/3 or 2.6 repeating, or 2 1/3. I don't really care. Let's say this time I do 8/3 and do my brace. And that is all for section 1.3.